Hello and welcome to Friday's edition of Cracking the Cryptic, where today we're going to be looking at the third puzzle in a trilogy. We've done the first two puzzles actually on the channel already. These are the Four Corners puzzles by Tallcat, and this is number 3. So it's just called Four Corners 3, although I think it's also called Vier Ecken. Its German equivalent. But the testers say this is a beautiful puzzle. I'm not surprised. I have to say Tallcat's puzzles have been impressing me greatly in recent months. And if you look at Logic Masters Germany, I think every single one of Tallcat's puzzles is sort of absolutely tip-top rated for ages. So this should be fun. I'm told as well it's approachable today, so we shall see if that is true. And I'll read you the rules in just a second. First thing I'd like to do today, though, is to make a plea. We need your help. So, many of you know that we have a whole suite of apps that we've released, which cover lots and lots of different types of Sudoku. We are very proud of them indeed. But we've had a bit of a hiccup on the Google Play Store, where they informed us a couple of days ago that they were taking down Thermo Sudoku and Miracle Sudoku. And you may ask why. Why were these apps taken down? Was it because they were badly rated? No, they are rated incredibly well, as they should be, because they are full of amazing puzzles. No, they were taken down for repetitive content. So somebody at the Google Play Store has decided that Thermo Sudoku and Miracle Sudoku are, I don't know what, too similar to other types of Sudoku or something. It is bizarre to us that this can have happened. We have appealed it, of course. A human being has reviewed that decision and concluded it was the correct decision so far. So we're a bit nonplussed by that. And what we're trying to do is, we're trying to appeal again and to find out what's going on. But I think anybody who watches and enjoys this channel would be able to make a pretty good case that a Thermo Sudoku is quite a different thing from, for example, a Killer Sudoku. There's a lot of different logic there, and it's a lot of different logic that people enjoy and want to see. So we don't understand why anybody, let alone Google Play, who make money obviously every time we sell an app, would like to take those apps down. So if anybody works for Google or the Play Store, if anybody knows anybody who has any influence in these things, please can you just appeal to them to take a look at this and sort it out, and let's try and restore some sanity to the world. I know the world is a strange place full of odd things that happen all the time, but this for us is quite an odd one. And if anyone can help us to sort it out, we would be very grateful. Now, anything else to mention? Well, just Bubba Is You. Tomorrow night, Mark and I are live streaming Bubba Is You again at 10 o'clock UK time. We would love to have your company. So please consider it if you're free. I'm not sure it's very sensible to do a stream on Saturday nights, but you know, my Saturday nights are always free. But I guess lots of people are busy on Saturday nights, even in a COVID world. But anyway, tomorrow night is when it is, and I will do the witness stream as well, probably next week at some stage. So watch this space for that. I'll announce it on Twitter, which is at Cryptic Cracking. If you don't follow us there, please consider it. Right, let's get on to the rules of Four Corners 3 by Tallcat. Oh, by the way, Tallcat. Whenever I think of Tallcat, in my mind it looks like the Cat in the Hat from Dr. Seuss. Is that? Am I alone in that? In which case, this puzzle should be full of, what were those things called with the blue hair? Thing 1 and Thing 2. So, yeah, this puzzle is going to be full of Thing 1 and Thing 2 running around, causing mischief and mayhem for all concerned. And in fact, if they have blue hair, maybe they've got some affiliation with Peter C. Hayward, who is the only person I know with blue hair. Peter, were you trying to be Thing 1 and Thing 2 out of the Cat with the Hat? I think you might have been. So anyway, we might find Peter C. Hayward lurking around in this grid as well. Peter, of course, being responsible for what's been helping us tremendously with our book, which is on the way very soon. Now, anyway, I'm getting distracted. Don't get distracted, Simon. Here are the rules. Normal Sudoku rules apply. Each main diagonal, marked in blue, cannot contain a repeated digit. So this is normal diagonal Sudoku rules. So those cells there all have to be different. All these cells also have to be different. Digits along an arrow must sum to the digit in that arrow's circle. So this cell here is the sum of those three cells. So we're getting attacked by a fly. If this was a 2, a 3 and a 4, 2 and 3 and 4 add up to 9, so you put 9 in the circle. And that's how arrows work. Another strange fly-like sound up there. I'm getting accosted from all sides. Adjacent digits on green lines must differ by at least 5. Right, so we've got German whispers today as well. I don't think the first two Four Corners puzzles had German whispers, but I might be misremembering. So how do German whispers work? Well, let's imagine this square here was a 3. Now, if this is a 3, this square here must be at least 5 different from 3. So it could be 8 or it could be 9, but it couldn't actually be anything else. So that's how German whispers lines work. Very interesting constraint. And in fact, someone suggested, oh gosh, my voice still isn't quite right, but someone suggested a sort of line Sudoku app, which I thought was a brilliant idea, because we've got all these lines going on in Sudokus at the moment. They all mean slightly different things, but if you put them together, you can make some mad and beautiful madness. So we've got, what have we got? We've got German whispers, we've got Renban lines, we've got palindrome lines, we've got equal sum lines. So between those 4 lines, you could make some wonderful puzzles. Anyway, let's get on with this. Do have a go yourselves. The way to play is to click the link under the video. Now I get to play. Let's get cracking. Right. Well, the first thing I see here is the 4 corners, which is appropriate enough given the title of the puzzle. So why are these interesting? Well, these are always interesting in diagonal Sudoku because they see each other. What do I mean when I say they see each other? Well, let's consider this cell here. This cell sees this, so let's highlight that cell. It sees this cell through the medium of Sudoku columns. So obviously whatever's there cannot be there. It sees this cell through Sudoku rows. And it sees this cell through the diagonal line. So this digit, the purple digit, has to be different from those 3 cells. But because the puzzle is 90-degree rotational symmetric with regard to that logic holds for this cell, and this cell. So these all have to be different from one another. And that, I think, is going to be immediately interesting because of the arrows. Because each of these circles has a 3-cell arrow emanating from it. Now, a 3-cell arrow is a minimum of 1, 2, and 3. 1, 2, and 3 add up to 6. So these digits here have to be at least equal to 6. Whoopsie, wrong pencil mark. And once they have to be at least equal to 6, and they're all different, they have to be a 6, 7, 8, 9 quadruple, which, right, I can see something that might be doing with regards to this square. Because if these are a 6, 7, 8, 9 quadruple, and they are, well, right, this is actually beautiful. Right, I know what this digit is. I actually do know what this digit is. So let's do this slowly. This cell, I've got another digit, this one. In fact, let's do this one first because this is a bit of a ricket by me. This is a very simple digit. Why do I know this digit? Well, look at box 5. It's the only cell in box 5 that is not on a German whispers line. Now, there is a problem with one digit on German whispers lines, and that digit is the digit 5. Why is 5 a problem? Well, it's because the next digit along the line has to be 5 different from 5, which means this square has to be 0, or a negative number, or 10, or higher, both of which are impossible. So you can never put 5 on a German whispers line, and therefore I could have immediately written the 5 in here. Oh, for goodness sakes, Simon. Sorry, I should have started with this. I just didn't spot it, but look at this diagonal as well. Where does 5 go on that diagonal? Well, the answer, in fact, I would have had to do the 6, 7, 8, 9 logic to note this, but I could have got, as soon as I got the 6, 7, 8, 9 logic, I could have seen, because of the whispers line, that square's the only place a 5 can go. But this is all a digression, because I want to get to putting thing 1 in this cell. This cell is the Peter C. Hayward cell of this puzzle. Why? Well, it's because it's got blue hair. No, it's not because it's got blue hair. It's because it is a 1. Why is it a 1? Well, let's come back to it. It's on a German whispers line. Now, the way I think about German whispers lines is by parity. Every cell on a German whispers line, because there's no 5 on a German whispers line, either has the property of being a low digit, i.e. a 1, 2, 3 or 4, or a high digit, 6, 7, 8 or 9. Well, we know that this central cell is not 6, 7, 8 and 9 because it sees every cell in the corners, so it's a low digit. Now, once it's a low digit, what low digit is it? Well, here the point is that, let's make it a low digit. Oh, it's got to be blue. It's got to be blue if it's a low digit because it's got blue hair. Now, once it's got blue hair, what are these 4 digits now? These are the next digit. These are next to a low digit on a German whispers line. Now, German whispers lines oscillate. So they always go low, high, low, high, low, high, or high, low, high, low, high, low. So once you know this is low, you know all 4 of these are high. And if all 4 of these are high, they are, yep, a 6, 7, 8, 9 quadruple. And what's the only digit that can now go in here? Thing 1. Because one of these digits is next to a 6 on a German whispers line. And a 6 can only be next to a 1 on a German whispers line because that's the only digit that's 5 away. If you add 5 to 6, you get 11, and you can't put 11 in the Sudoku. So this digit is a rather beautiful 1. And that means what exactly? I don't know. Those 3 squares are now 2s, 3s and 4s. I suppose they're all low, so they should be blue as well. Right, come on, Dr. Zeus. What do I do now? Right, I know one thing I can do. I now know the parity of all 3 of these German whispers lines, don't I? Because they've each got a low digit at this end. So that must be high, that must be high, and that must be high. And then the next digits along are going to be low. Which means what then? Is that helpful? It might be. 6 on the negative diagonal is now interesting a little bit. Or is it? No, it is. It is. That's got to be higher than 6. That's got to be higher than 6. Yeah. Okay, so look at the negative diagonal. These 2 squares here cannot be 1s, and therefore the next cells along their German whispers lines have to be at least 5 different from 2. And that means they're at least 7. So these 2 squares here are 7, 8 or 9. And that means that the 6 on this diagonal is in one of the corners. And therefore, you can't put 6 in either of the other corners, because if you do, you can't now put a 6 at all on the negative diagonal. So these 2 squares are not 6s. Which might be important. This square here is 2, 3 or 4. I'm not sure why I cut it, given it looks like I'm resorting to just pencil marking them all. Sometimes with German whispers it is useful to pencil mark them because of the weird interactions. Yeah, I mean, for example, that square cannot be a 7. And that's only become apparent to me since I've just pencil marked those digits, because why can't it be a 7? Well, what would I have to put in both of those squares? A digit 5 away from 7. Well, the only valid digit in both positions is a 2, and you can't put double 2 on the diagonal. So that's not a 7. 2, 3, 4 here means this square has got to be not 6. So that's going to be 7, 8 or 9. Actually, I almost didn't scan that, but my eye just caught the bottom left of the grid. There is a 7, 8, 9 triple now on the positive diagonal. There's also a 7, 8, 9 triple in those squares as well. Because of the diagonal, these 3 see each other. So in ordinary Sudoku, this cell wouldn't see that one. But because of the diagonal, it does. So these 3 squares are all different, and that's worth highlighting, I think. These are all different, and they are a 7, 8, 9 triple. They're all different, and that's a 7, 8, 9 triple. Does that mean anything to anybody? Now my phone's starting to buzz at me. I don't know. Not sure. I think I'm going to resort to filling in these digits. So this digit here has to be 5. Oh, it's just not restricted at all, is it? No, it's literally completely unrestricted. That is fairly hopeless. That one also is completely unrestricted. Bobbins, right. That's not how to do this puzzle. Okay, so we've got to think again. What is it that we're meant to do here? So maybe it's this digit. This one can't be 7 because you'd have to go... It's quite clever the way Tallcat has set this up. I think this is by far the most restricted German Whispers line because it's the only one where we have a real restriction on the two, these two, which have to have the same parity. It's 1, 2, 3, 4. Oh, I see. Right. That's really lovely, actually. Okay, well, I want to look at this digit. What I was about to say, well, the way I got what I'm about to say is I was wondering whether this was the 6, because the 6 on the negative diagonal is in one of 2 places. I was wondering whether it could be here, because I could see that was going to restrict this square. Now, in fact, it can't be here, but the reason is not really, it's a bit independent from this square. This square just can't be a 4. Why can't this square be a 4? Well, look what happens. Now in the central box, we've got to put a 4 somewhere, and it can only go here. And now what do those 2 squares have to be? They're both on German Whispers lines next to 4s. They both have to be 9s. And that can't work, because they're both in the same row of the Sudoku. So that means this square here is not a 4. The corollary of that, of course, now being that this square here is not a 6, because you can see if that's a 6, 1, 2, 3 go in those squares, and this square has no value. So that means the only place 6 can go now is here, in terms of the 4 corners. So we know that the 6 lives there. We know this is a 1, 2, 3 triple, therefore. The world's most useless 1, 2, 3 triple. Yes, you have been awarded that prize. And 4 in the central box has to be in one of those 2 squares, which means it's not here. And if that's not a 4, this square is not now a 9. Oh no, that's not right. That's nonsense. It works the other way. Simon, get a grip on the world. 4 is in one. No. Yeah, the way to think about this actually is... No, I can still do the same thing, actually. I'm going to just do it in a way that's logical rather than nonsense. So we're going to apply the principles of logic rather than complete and utter drivel. Now, how do we apply the principles of logic rather than drivel? We look at these 2 squares. Now, these 2 squares include a 4. I don't know which one is a 4, but they're both on German Whispers lines, which means one of those 2 squares is a 9. And if one of those 2 squares is a 9, that square can't be a 9, can it? Because this sees both of those squares, where there must be a 9. So this is not a 9. Now, this is really clever. This is really clever. This is what Tallcat does. Now the 9 on the positive diagonal is in a corner. So that can't be a 9 anymore. So this circle now is a 7 or an 8, which means it must have a 1 on its arrow. It's either 1, 2, 4 or 1, well, 1, 2, 5 or 1, 3, 4. There are 2 ways of making 8 in 3 cells. Okay. We also know, I suppose, that whatever this digit is the same as that digit, which is an interesting thing to note. And that's because whatever this is ruled out of those 2 squares and therefore has to complete there. So you sort of get some T pentominoes that you can rule this digit out of in boxes 2 and 4, but I'm not actually seeing much more than that. Ah, okay, but we can extend that logic, can't we? What about that square? Yeah, this is lovely. This is absolutely lovely. Right, let's come back to the purples. The purples are a 7, 8, 9 triple. Now, on this negative diagonal, these 3 squares are also a 7, 8, 9 triple. And you can see that these 2 squares are in both of those triples. So these 2 are obviously in this triple, and they're in that triple. Now that means those 2 squares must be the same. And if they're the same... Oh, I'm running out of good colours to use here, but bear with me. These 2 are the same. So one of these 2 squares is now red. One of those 2 squares is red. Can we do more than that? The answer is I'm not sure, actually. I'm not sure I can. Ah, yeah, this is important, actually. Let's come back to this. I was trying to see whether I could do something by Sudoku, but I think what I've got to do is to think about the whispers lines. If that's a 7, I think this has to be a different... I think this has to be 8. If that's a 7, you'd have 1, 2, 4 on this arrow, which means this is a 3. But we know if this is a 3, it transposes here. So let's do this slowly. You go 7 here, which forces 3 here, which we know forces 3 here because we have to have a 3 in one of those 3 squares. Now this 3 needs now this square to be an 8 because it's got to be 5 away. But we know that from the geometry of this triple, we know this has to be a 7. So this cell simultaneously has to be a 7 and an 8, and it can't do that. There are no such things in Sudoku as Schrödinger cells. So this is not right. This is not possible. And therefore this square here must be an 8. I love things like this. It's so intricate. Now if that's an 8, we know that's an 8 because we know they're the same. We now know that this square's a 7 because we've finished our triple here, and indeed we've finished our triple there as well. That square's got to be 5 away from 7, so it can't be 3 or 4. That's a 2, which places a 4 here, which makes sense because that's next to a 9. On the whispers line, that square's a 3 now, which makes sense. That square's not a 2 or a 3 or a 4 because it's next to an 8 on the whispers line, so that's a 1. This square has got to be a 1 or a 2, and it can't be a 2 because it's got to be 5 away from 7 again. And this square's a 3. And that fixes the 8 arrow, which is now 1, 2, 5. And the 1 is not here. And we've got an 8 there, so we can eliminate 8s from the other 2 corners. So we're left with the 7s and the 9s we've not finished. And on this diagonal we need 2, 4. What do we need? 2, 4, 2, 4, and 6 into those gaps. Yeah, that's... Sorry, I'm just checking that. For some reason my brain was resisting scanning with the 2, 4, 6, but I think it is a 2, 4, 6 triple, and that's very helpful here. This can't be 7 Because if this is 7, you've got to put 1, 2, 4 onto those cells, and then both of those cells must be double 6, which is nonsense. So that must be 9, I think. And therefore this must be 7. This must be 1, 2, 4. Oh, and if this is a 1, 2, 4 triple, and it is, that's not 1, that's not 1. So this is 1. Those are 2 and 4, so this is 6. There's a 6 in one of those 3 cells by Sudoku, a 6 in one of those 2 cells by Sudoku, a 6 in one of these 3 cells by Sudoku, an 8 in one of those 2 cells, although I'm going to get rid of that colouring because it's a bit off-putting. 6 here means these 2 squares are a 2-4 pair. Now that's going to put pressure on the 9 arrow, which now can't be 1, 2, 6 or 2, 3, 4. So this is a 1, 3, 5 triple. That's not 5. That's not 3. Okay. So those 3 squares maybe, they've got to be 3, 5 or 9. 5 is a bit restricted. So we can ask where 5 goes in row 3 now. It's got to be in that domino. Is there any other correspondence? There's going to be a correspondence with 4s as well, I think, because the 4 in box 1 has to be in one of those 3 squares, and it's the same looks. It's locked into the same 2 rows in box 3. So 4 in the simple question to ask, which I could have done, but never do it the simple way, as you know, is to ask where 4 goes in row 1. It's got to be in one of those 2 cells. These 3 squares are 4, 8 and 9. So again, the 4s marry up. We ask where the 4 goes in this column. It's got to be in one of those 3 cells. 3s also marry, so the 3's in one of those 2 cells. I don't think I'm doing this in the most efficient way at all. What about those? They're 6, 7 and 8. Right, there's not too much correspondence there, and those ones are 4, 6 and 7. Again, that's not actually that useful, so maybe we've got to do, is it the short German whispers lines? What am I missing here? I can't see. Oh no. I suppose that, oh yeah, it is actually, it's this one. It's this one. It sees 1, 2 and 3. Now, it's a 2-cell German whispers line, so it has 1 low digit on it and 1 high digit on it. Well, its low digit is now a 4, because it sees 1, 2 and 3, which means its high digit is a 9, and there's a 9 in the corner. So this square's a 9, this square's a 4. That's very clever. So that's not a 9. Although I'm not actually sure it does anything. That's... oh, bother. 4 in the top row is now a bit interesting. 4 can't go there, so this has got to be a 4. Five is interesting as well in box 8. This 5, and there's a 5 in one of those, and there's this 5 here, so that's a 5. That's a 5. Right, okay, and now I can look at column 6, where I think I've only got 6, 7s and 8s to find. So that square is a 6, it's a naked single. And therefore this square is a 7, oh, whoopsie, this square is a 7 or an 8. This square is a 7 or an 8, and it sees 7, so that's 8. Oh, this is good. This is actually good. So look, I can get rid of the 7s from those 3 squares. Actually, I can place a 7 as well in box 6, I've just noticed, so I better not look gift horses in the mouth. But this 8 as well is giving me an 8 down there. And that's a 4, 9 pair. Well, that's looking at that square, which is a 2 now. That's a 4. This 2 is huge. It's giving me lots of joy in box 1. And I approve of anything that gives me lots of joy. In fact, that square's now a 9. This is 3, 5, so that's a 9 by Sudoku. We need a 9. Good grief! And suddenly we're actually, well, I'm not going to say we're cooking with gas, but we have made some progress. This 6 here is powerful. That's going to give us a 6 here. So that's a 7, 8 pair. This square here is a 1, 2 or 3 to complete row 9. 8 in box 6 is locked into exactly that cell. So this is an 8, that's a 6. This is now an 8, 9 pair in the column. 6 in box 8 is forced to be exactly here. So this column is probably where we need to look next. Let's just finish. That's an 8 now, just tidying up our pencil marks. We need 2s, 3s and 7s into this box. Oh, good grief, that's absolutely hopeless. 2, 3 and 7 go in there. That's not a 3. Wow. Oh, there's a 6 there, though, that's doing something. So this square here is now 4 or 7. Oh no. Yeah, I think disaster is striking. What about that square? That square's 2, 3 or 7 again. It's no good. We've got a sort of 2, 3, 7 triple in column 5 that's not actually useful. I find it hard to believe it's this one. Is it this one? Oh, it is. Oh, it's the same again. That square, unless I'm missing something, is seeing 1, 2, 3 and 4. So that square's high. Although it doesn't see any high digits. So I think it's 6, 7, 8 or 9. This square is low, so this is 2, 3 or 4. This can't be 6 then, because this square can't be 1. Oh, it can't be 3. Yeah, that's might be important. You can get rid of 3 from this square, so this is 2 or 4. We know if this is 4, this will be 9, which looks almost likely, doesn't it? Because 9 in the column would be in the right string of 3 digits in box 4. We just need to get rid of 2 or 4 from this square. How do we do that? Oh, I can do it. I can just do it by Sudoku. There's a 4 there. So that means that's not a 4, which means 4 is in this column. It's in this domino in box 1, so that's 2. Oh, which doesn't fix this digit. Oh, rats. So 2 is in one of those 2 cells now, in box 6. Okay, that's a bit disappointing. So how do we make more progress now? The answer is I don't know. I suspect we may have to... Oh, I can do something. 9 in box 6. It has to be in one of those 3 squares. So that means that's a 4 and that's a 9. That's a 4 and that's a 2. That's a 7 and that's a 4. Ah, here we go. So now we're left with a 6, 7 pair here. We're left with a 2, 3 pair here. This 7 gets rid of a 7 from that cell. 2 in box, this box here has to be exactly there, which looks like it might... Ah, that would be helpful. It does. It leaves a 4, 6 pair behind, and there's a 6 here. So this is 6. This is 4. This is 4 by Sudoku. One of those 2 squares is a 6 by Sudoku. These squares are now known. They have got to be 3, 5, 9. And that's not 3. That's not 5. So 3, 5, 9 triple. This 2 is helpful. That gives us a 2 at the bottom of the grid, which means that square is also not a 2. A 2, 3 pair and an 8, 9 pair to finish off in column 5. Where does 7 go? In column 4, only in exactly that square. Now that is very important because I've just now noticed I've got a 1, 3 pair in row 8. So that's a 2, which means that's a 2 and that's a 3. This square here is a 1 or a 3. Oh, it's still not actually tidied up though. Ah, but this square is a naked single now, because look at row 5. We haven't placed 3, 5 and 9, and this square can only be a 3 of those options. That means this square is a 7 or an 8, and it sees 7. So that's 8, that's 7, that's 8. That gets me my 8, 9 in the middle. Gets me a 5 here, 9 here, 3 here. Those two squares are a 1, 6 pair, I think. This can't be 8 anymore because it sees this square. So these squares are 5, 7, and 9, and that must be a 5. And I can see that's useful. 1, 3, 5, 1, 3, 1, 3. This is a 7, 9, but the only place 9 can go in box 4 is here. This is a 7, that's a 7, 6, this is a 6, 1, and we should be able to tidy up like that. And now we will click tick, and we have done the puzzle. What a lovely, lovely Sudoku puzzle. It was approachable today, and it just required some sort of careful thinking around these whispers lines, but it's classic tallcat. It really is. You have to appreciate that there's an awful lot going on between these three cells, and this cell, and they sort of all interact with each other and play ping pong and boomerang around. Well, we did boomerang yesterday by Sam, didn't we? But this also has boomerang elements to it. And I did enjoy that. That was a very, very fun puzzle indeed. I hope you did too. Let me know in the comments. I do enjoy them, especially when they're kind. And anyone who can help us with our Play Store nightmare, please step up and help. We would be most grateful. And we'll be back later with another edition of Cracking the Cryptic.